In this video, we're going to find the equation of a plane that contains 3 points. These are the 3 given points. Now, if I wanted to visualize what was happening, I might try to graph this, but graphing 3-dimensional points on a 2-dimensional piece of paper is difficult to do, and then even when I do it, because of the perspective that we're looking from, the picture that we see might not be very insightful. So often what we do, instead of graphing the actual plane, is we graph a cartoon of the plane. So here's a cartoon. And I know that at this point, I know that these 3 points lie in my plane. I'm going to call them A, B, and C. So let's say A is here, and B is here, and C is there. And we want to find the equation of a plane. Now we know from the previous video that to find the equation of the plane, we need a normal vector to the plane. So that's a vector that meets the plane at a 90-degree angle. It has components A, B, and C, and a point in the plane. Given the normal vector and some point in the plane with coordinates A, or with coordinates x naught, y naught, z naught, or P is just any old point in the plane, the equation of the plane is given by A times x minus x naught plus B times y minus y naught plus C times z minus z naught, and that equals 0. And we derived that using a dot product of this normal vector and the vector from this point, x naught, y naught, z naught, which is just some point in the plane, to some other general point in the plane, x, y, z. If you want more information about where this formula comes from, watch the last video. Now this time we're not given the normal vector to the plane. We've got 3 points, so any one of these could be x naught, y naught, and z naught, but I don't have A, B, and C. So the question is, how do we get the normal vector to the plane, or a normal vector to the plane, if we know 3 points in the plane? Well, I think we're going to do the same thing that we did in the last section. It's something that we do often. If someone gives me 3 points, or if someone gives me a number of points, and they're related to some geometric object, if I want to find, if I want to use vectors to find out something about that object, I just start drawing vectors between the points. So we could create a vector from A to B and A to C, or B to A and B to C. We actually don't even have to start at the same point. We could do the vector from A to C and then the vector from B to C. That would be fine. Any 2 vectors would be fine. I think I want to do the vector from B to C, or from B to A, and the vector from B to C. Now both of those vectors are in the plane. So I've got BA is in my plane, and C, or BC, is in the plane. And the question becomes, if I've got 2 vectors in the plane, how can I find a vector that is normal to that plane, or perpendicular to both of those vectors, or we say orthogonal to both of those vectors? I hope you remember from the last section, cross product. If this is the vector u and this is the vector v, the cross product of u and v is either pointing this way, it's pointing up from the plane containing u and v, or it's pointing in the opposite direction. One is u cross v and the other one is v cross u. So if I want this normal to the plane and I'm given 3 points, it's actually pretty easy. All I have to do is find a vector from here to here, and find a vector from here to here, and take their cross product. And I know that the cross product of those 2 vectors has to be orthogonal to both of them. It's going to give me a vector that's orthogonal to both, which is the normal vector to our plane, or is a normal vector to our plane. So let's calculate these 2 vectors. If you're finding the vector from B to A, you start with the terminal point, which was A. So 3, -1, 2. And then you want to subtract the coordinates of the initial point. So we're going to subtract 2 and 1 and 5 from this. And then we'll simplify. That gives us 1, -2, -3. And then down here we're going to do the same thing. Start with a terminal point, which I chose to be C. Take its coordinates. And then from those we're going to subtract the coordinates of the initial point, which is B. So subtract 2 and subtract 1 and subtract 5. And then simplify. We get -1, -3, -7. Okay, so the cross product of these two vectors is orthogonal to both of them. That means it meets that plane that contains both of these vectors at a 90-degree angle. So we're just going to use the determinant form. Let's find the cross product. In this row, we'll write 1, -2, -3. In this row, we'll have -1, -3, -7. Then to find the components, we're going to cross out the row and the column containing I hat, and then we see this 2 by 2. You want to take the determinant of this 2 by 2 matrix. So you multiply across this diagonal. -2 times -7 is +14. And multiply across this diagonal. -3 times -3 is 9. And then you subtract them. And then you always subtract what you get next. We're going to cross out the row and column containing j hat, and we're going to look at that 2 by 2. So in the top row we've got 1, -3. In the bottom row we have a -1, -7. So we multiply 1 times -7 is -7. And multiply -1 times -3 is +3, and you're subtracting. And then we cross out the row and column containing k hat. And now you've got that right there. Multiply across this diagonal, you get -3. And then multiply that across that diagonal, you get 2, and you subtract. So we have 5 here. That's minus a -10, so that's +10. And -5. So this is one normal vector to our surface, to our plane. And notice all of these are a multiple of 5. We could use this vector, but it's actually 5 times longer than it needs to be. I usually like to keep my normal vector with the smallest integers possible. Because remember that 5, 10, and -5, that's going to go here in this equation. We're going to have a 5, a 10, and a -5 times some quantities and equaling 0. We could take that equation and we could just divide everything by 5 and we'd get an equivalent equation. In the same way, I can take this vector, which is perpendicular to this plane or normal to this plane, and instead of making it really long, I could make it 1/5 as long. So it's just down here. So we can multiply this by any constant. It's still going to be normal to the plane. If the constant is positive, it's just going to change the length. If we multiply by a negative constant, it's going to flip it and it's going to put it in the opposite direction. Because I'd like that to be a +1 instead of a 5, I'm going to choose the normal vector. That's 1/5 of that cross product. So 1/5 of this vector is this vector. 1/5 of 5 is 1, 1/5 of 10 is 2, 1/5 of -5 is -1. So that's our ABC. And now we have everything we need to write down this equation. We needed a normal vector, and we have it. We found it by finding two vectors in the plane and then taking their cross product. And then we rescaled it just to make this equation as simple as possible. And now we can use this and any one of these as x naught, y naught, and z naught and substitute into that equation, and we'll have the equation of a plane. So I'll call this one x naught, y naught, z naught. And I'll write my equation of the plane in standard form. So we have A, I'm going to fill that in a minute, times the quantity x minus x naught, plus B times the quantity y minus y naught, plus C times the quantity z minus z naught equals 0. A, B, and C are 1, 2, and -1. And x naught, y naught, and z naught are 3, -1, and 2. So we have a 3 here, a -1 here, and a 2. So that's our equation. It's just not simplified, so let's simplify it. Let's write it in general form. We can distribute, so we just get x minus 3, distribute the 2, that's 2 times y, and that's going to be a +1, 2 times +1 is +2, and -1 times z is -z, -1 times -2 is +2. So we've got -3 plus 2 plus 2, that's -3 plus 4 is 1. So I've got the x and the 2y and the z plus 1 equals 0. That's general form in some books. In other books, they like to put the constant on the other side. I think that's the one I prefer. I like to have my constant on the right-hand side. In our class, either one of these will suffice as general form. Okay, so that's not too bad. We have just found the standard form and the general form of the equation of a line. Or I said line, the equations of a plane. So that's it for this video. I will do more applications or more problems involving planes in the next video.